We were doing, what were we doing? We were doing the parent functions when we talked about the the guide on the parent functions. I'm trying to remember what else we were doing last week. Um, I know that we covered that whole absolute value and we were moving those absolute value graphs uh, um, around, and we talked a little bit about graphing the quadratic functions and how they change. And today we're kind of doing that a little bit, but what we're working in is what we call vertex form. We're trying to get something in vertex form. And if you remember when we did the absolute value, it was really important to kind of find that vertex, because that vertex told us where to start the graph and how to fill in the tables. Today we're going to talk about um, vertex form of a quadratic equation and putting the equation into an actual vertex form where we can see the vertex in the equation, so that we know how to graph it. And so the vertex form of a quadratic equation is this little wheel thing that just popped up, is f of x, which is how we read that, equals a times x minus h squared plus k. And if you remember that hk, when we were dealing with circles, was the center of our circle. In this case, it is the vertex point of um, of our equation. So if I have the point hk, um, they have is there, which is just bad English. The x value of that vertex point is h, right? And that is our axis of symmetry. So this point that we would see right in here, oops, that was supposed to be an arrow and wound up looking nothing like one. This h value right here would be that x value, or that axis of symmetry that we were using the other day when we were graphing. Remember when we were trying to find the axis of symmetry? If we put the equation into this form, then we can find our axis of symmetry. It shows us our vertex, and we know where to start the numbers on our graph. Um, A, this part A in front, is what determines the width of the parabola, how wide it's going to be, because that is something being multiplied by the parabola. If it's a fraction, the width is going to be really narrow. If it is actually, if it's a fraction, it's going to be really big, the width. If it's a whole number, it's going to grow fast, right? And it's going to be a very narrow width. Vertex form shows the vertex on a quadratic equation. It's why we call it the vertex form, because in math we are not original. We name things after what they are. It is the vertex on a quadratic equation in respect to its parent function. And the parent function of a quadratic equation is me moving this thing around way too much. I gotta like fix the sensitivity on this thing. Is f of x equals x squared. Man, I cannot use my tablet today. I was thinking about just like, I have this overhead monitor, and I was thinking about just doing stuff on paper with like a zoom on the paper just to make my life easier. But then it doesn't record right here to the thing. So when we're talking about comparing things to a parent function, which is what we're moving towards, we have done this. We talked about Like if something's happening inside the parentheses, it's happening to x, and if it's happening outside of the parentheses, it changes your y value. And so we're going to look at this and we're going to see how each of these compare to the parent function. If we look at our parent function is f of x equals x squared. So if I have f of x equals x squared plus 9, that is just taking the shift of the parent function, and every point on it would move up 9 spaces, right? 9 units. If we looked at our f of x equals x squared minus 2, that would just be a shift down 2 units. Make some sense? Yeah, kind of. Again, if we look at number 3, there's a lot going on. We have this happening on the inside of that parentheses, not on the outside of that parentheses. So that is something that's going on with the h value, right? The x is moving. And if you remember correctly, when it was positive, it was moving to the left 5 units. And then that negative out in front, if you remember, was a reflection across the x-axis. So this is going to reflect on x and move to the left. And so the first part of the assignment that you're going to get is you're going to have to fill in like a little chart on your homework of what shifts are happening. So you have to kind of understand what's going on in these parts. If we look at this one, inside the parentheses, we have a minus 4. That is a shift right 4. But we have this minus 1 on the outside, so it's also going to go down 1. And that transformation guide that we filled out should really help you with this, right? You can have that guide that we filled out. And I believe I also posted a completed version of it in Google Classroom. And I recommend when you're doing these to have that out so that you can kind of see how all of these changes are made. If we look at number 5, remember how I said that if it's positive, like if it's a number greater than 1, you're going to have like a vertical stretch, right? It's going to grow up really quickly. And if your A value was a fraction, if it was less than 1, it's going to kind of go wide really quickly. In this case, we have so this is like a vertical compression, right, by 1/3. So this will compress or shrink vertical by 1/3. What else is happening on here is it's also going to be moved up 2 places. Number 6 has a ton of stuff going on, right? If we look at number 6, we've got that -2, right? Which means that it's going to reflect across the x-axis because it's got that negative. It is going to reflect across x-axis. It is going to stretch. You're going to have a vertical stretch times 2. Granted, it'll be going down, but it'll stretch really fast compared to the parent function. And then we would move to the left 4 units. So when you do these, bust out that chart we made when we were doing it with the absolute value ones. It works the exact same way, right, when you're moving those around. I am not going to bother with this problem. Um, Today, the problems that we're doing are already going to be put in Vertex form. We are just going to show how to use the form. When I see you later this week, we're going to be converting equations into Vertex form, which is much harder. So today is the easier part of the assignment. A lot of people turning their cameras off. Let's not be doing that, please. So if we look at this problem, our vertex says give the vertex an axis of symmetry of each equation or inequality. I took the inequalities off, so we're not going to move into that today. We're just going to deal with it with equalities, and then we're going to graph them. If we look at this problem, or that problem, if we look at number 8, we can find that vertex. Our vertex is really easy to find because this is in vertex form. Our h would be 2, and our k would be 3. And that is our vertex point. It also says, give the axis of symmetry. Well, the axis of symmetry, that AOS, is just the x value of your vertex. So it would be x equals 2, right? And we're going to use this again to build up our table so that we can make a graph. And we're going to start by putting this 2, 3 in the center, and then we're going to pick points around it on both sides because, like absolute values, quadratics, these parabolas that they form, are also symmetric, right? So if we know this axis of symmetry and we know the vertex, we know everything's going to be symmetric around it. So we're going to build our points. So we'll call this one 1 and 0. We'll call this one 3 and 4, and those will be the x values that we plug in to find the other points. What do I plug them into? I plug them into the original equation. And I'm going to do it in this funky green color just so that we could tell it's separate from what we've got going on up here. But our equation is this x minus 2 squared plus 3. And if I plugged in 1 for x, I would have 1 minus 2 squared plus 3. 1 minus 2 is negative 1. And if I squared negative 1, it would just be 1 plus 3, which is 4. And then we do it again for 0. Well, 0 is really easy because if I plug 0 in, right, that would be 0 minus 2 squared plus 3. That's just negative 2 squared, which is 4. 4 plus 3 equals 7. And I will know that this repeats on the other side. Can I plug them in and prove it? Yes, I can, right? But we know that it's symmetric, so I know that after that vertex, as long as I keep my points at an equal distance apart, they're going to repeat. And so I can plug these in now, and I can go, okay, well, at x is 0, we have a point at 1, 2, 3, 4, 5, 6, 7, and at 1, we have a point at 1, 2, 3, 4. And at 2, we have a point at 1, 2, 3. And that is going to repeat, right? At 3, we're going to have a point at 4. And at 4, we're going to have a point at 7. And you can kind of see how our graph is formed. And we can do that because we are in vertex form, right? If I don't have that parentheses, if we look at number 9, this is still in vertex form. It's just nothing's going on with that x value. So there's no need to have anything in parentheses. So if we were looking for the vertex on a problem like this, and we don't have that parentheses because there's nothing more we can solve it on, it just means that that x value of our vertex is 0. And then that y value is going to be -4, or our HK, right, is our point. And we know that our axis of symmetry, AOS, is x equals 0, because it's always the 0 value of, it's always the x value of our vertex. Jacob and Olivia, is there a reason you guys aren't on camera right now? Still? So we know our center point, so we can plug it in. I can go, okay, well, this is 0, this is -4, and I can build my points around this. So I can make this -1, and oops, that's not a 1. This -1, and this -2, and here I can do 1 and 2, and I only have to solve this equation for one side of the vertex, right? I could go, okay, well, I'm going to go -2 squared minus 4. That's the same as saying 4 minus 4, which is 0. And then I'm going to do it for -1. I'm going to go, oh, -1 squared minus 4 is 1 minus 4, which is -3, right? 1 minus 4 is -3. And I know that these are just going to repeat. And so when we go to make our graph, it's fairly easy. We go, okay, at -2, I have a point at 0. At -1, I have a point at -3. At 0, I have a point at -4. 1, -3. And then we have another point right here, and we can draw our graph. Does this make a little bit of sense? I am going to take your silence for yes, that it makes tons of sense, that you guys understand this so well. You don't even know why I'm still going. But I am still going to do another one because we've got bigger changes to be made on here too, right? If I look at this next problem, we have that negative on the outside, and we really don't have to worry about that in regards to right now. But what I do know is that this graph better open down, right? Because positive graphs open up, positive parabolas open up, negative parabolas open down. And so we know right away if we screwed up when we're graphing, if it's pointing in the wrong direction. Our vertex is going to be -5. And the reason that it's -5 is, if you remember, the standard form is a times x minus h plus k. So this minus h, if I pull something there and it's negative, I'm getting just that positive number. I only care about h, right? But if it's positive, then we had to put in a negative number to make it positive. So I know that if this is a plus inside this parentheses, that we've got a -5 for our vertex. And that only works on the h value, that x value of the vertex, not on the y. And we also learn now that our axis of symmetry is x equals -5. And so we can plug that in as our center point on the table. Maybe if I can make this thing stop moving. And I could go, okay, well, at -5, I have a point at -1, and we're just going to put in 2 points next to it, -4, -3, and then here we'll go -6, -7. It's just 2 points on each side. You should always have at least 5 points when you're doing a parabola. You should have your vertex, and you should have 2 points on either side of your vertex in order to graph it. cannot find where my mouse went. So when I look at the equation, I'm going to go, okay, well, I've got negative 3 plus 5 squared minus 1, and that's going to be negative 2 squared minus 1, which is 4, but it becomes negative 4 when we apply that, minus 1, which is negative 5. And then I'm going to do it again for negative 4. I'm going to go, okay, well, I've got negative 4 plus 5 squared minus 1, which is 1 squared, which is just 1. But I have that negative, so it's negative 1 minus 1, which is negative 2. And I know that they're going to repeat on the other side. And I can also tell just by looking at this that this is going to open down. And so that means that when we graph it, we should be able to see that it works out okay. So at negative 3, 1, 2, 3, 1, 2, 3, 4, 5. Negative 4, we have a point at 2. Negative 5, we have a point at, I don't even know what I'm doing there. I'm going in the wrong direction. It'll be the right direction on the other side. If I was going backwards, it would be. So at negative 3, 5, we have a point. At negative 4, 2, we have a point. At negative 5, negative 1, we have a point. At negative 6, negative 2, and at negative 7, negative 5, and this would be our graph. Last problem I'm going to do for you today is number 11. All right, when I do number 11, it is going to have a vertical stretch. And I know that because it's got that 3 out front, which means that it's going to be like a skinny parabola. It's going to grow rapidly, quickly. But it's sort of irrelevant when we're just looking for the vertex and the axis of symmetry. When I'm looking at the vertex, I just know that it is going to be 4 for my x value, and then my y value is going to be 0. How do I know it's going to be 0? There's nothing plus or minus on the other side of that parentheses, right? There's nothing being subtracted. There's no k value. If you look up here, we have this plus k, and that gives us our k or our y value, and that not being there means that it is just 0. So that is going to be our center point. We're going to have this center point at 4, 0, and then we're going to build points around it. Man, maybe we're going to build points around it. Our axis of symmetry is 4, but I'm not going to write it down this time. This one's going to be, we're going to put in 5, we're going to put in 6, and then we're going to plug these numbers in. So at x equals 2, I'd have 2 minus 4 squared. Well, 2 minus 4 is negative 2. When I square it, that's just 4. 4 times 3 is 12. These numbers feel big to me, right? But it's because we talked about that. They're going to grow really quick because they have that stretch on them. 3, if I plug in 3 here, that's going to be 3 times 3 minus 4, which equals, when I square that, 3 minus 4 is -1, and when I square -1, I just get 1, and 3 times 1 is 3. And so here we'll have 3, and here we'll have 12, because we know they repeat, because we know they're symmetric. And then when we go to plug that in, I can go, okay, well, at 2, 12, that's going to be like up here, right? Then at 3, 1, 2, I don't know, I'm on the wrong side. 2, 12 is up here, right? It's not even on the graph. At 3, I have a point at 1, 2, 3. At 4, I have a point at 0. At 5, again, I have a point at 3, and at 6, I have a point up here at 12. And we can now just play connect the dots. So I am not assigning you. I don't know if I assigned you any with the piecewise. I like you guys to try those out on your own anyways, but I'm not going to do those in the notes. This is pretty much all I'm doing. I didn't assign you any of the inequality stuff, so I'm not even going to go over it with you. Inequalities, just keep in mind the only difference is if it's less, then you'd shade that whole area under your parabola, and if it's greater, then you'd shade in that whole area above your parabola. But this is really it for the notes. Again, you are doing a worksheet. Like I said, later this week, we should be able to work out what we're doing in Delta Math, but there really wasn't anything in Delta Math to give you for this. And I thought it would really help before we have to start putting them into these forms ourselves. That to start with them actually in vertex form, so you can kind of understand why vertex form is really useful when we're graphing these kinds of problems. I am not going to keep you any longer. You are welcome to go. If you have any questions, stick around. I'll stay until everybody is gone, and there'll be tutoring today at 2 o'clock for anybody who wants it. But otherwise, have a great day. Have a good Monday.